Good afternoon to all of you. Thank you for inviting me here today. I'm very glad to present about this subject and to be with my colleagues from Microsoft and Thales. To introduce quickly myself, so as you probably hear, I'm French. I've been located in Singapore for the past 6 years now, and I was before working for STMicroelectronics in Grenoble in France for 9 years, after a few years in Germany where I was at Thomson Multimedia, now called Technicolor. Okay? But the comment of François about attractive area for R&D is very true, especially in our center in France, in Grenoble. Many engineers are there because they like the outdoor quality of life of the Alps. My speech will be about global R&D organizations and in particular about semiconductor packaging, which is my work. And packaging is not what you may think of, plastic bag, carton boxes, or bottle. It can be that. But you will see through my slides, which may appear a bit technical. I will try not to make you packaging engineers, but at least to make you understand why the R&D in packaging has a lot of value to be global and to be in particular in Asia. Okay? So there will be two parts in this presentation. The first part will be about the need of a globalized R&D, and the second one will be the advantage of Asia in this value chain of R&D. So first, let me start by the chain in the field of electronics. Okay, you have in fact three speakers today from the electronics or IT industry, I would say. The first users of the electronic components are for sure the electronic equipment manufacturers, whether they are from the mobile phone, the computer, the cars. You may know that there is more and more electronics in cars now, and even in the medical industry. And these are recent year data. The finished equipment value in terms of electronics is in the range of 1.5, a bit more than what you see here, $1.5 billion a year. Okay, those equipments are fed by components, which come, and you have here some phones which are opened, and you see plenty of components on those phones. They are fed by a lot of components that you see here, and EMS are the systems or the companies which are building those components by placing the components one after one on the boards. Okay, the value is in the range of $170 billion, and you can see that the gross margin is, by the way, much lower than those companies, 6% compared to 30%, and the R&D we will see is also much lower than what you see in finished equipment. That's where we are now, the active components, which are active because they are semiconductors. It's not only resistance or capacitors. You can see chips here, packages. This is a silicon chip inside a package, and I will bring you through this technology a bit more now. What you can see is that there are two fields. One is the manufacturing of the active chip, okay, the silicon, and the what we call integrated circuit assembly services, so the fact that we put this chip inside a package. Okay? Those two go very well together, and in fact for companies like mine, STMicroelectronics, we are what we call an IDM, so integrated device manufacturer. We do the chip and we do the package. Some people are only doing the chip and they subcontract the assembly in the package to some other companies which are specialized in this field. Those specialized companies are called Amkor, ASE, Spiel, and so on. The number one in the market, in our market, is Intel. They are mastering fantastic technology, mainly driven by the computer with advanced microprocessors. You can see that the gross margin of our industry is in the range of 40%, and the R&D is in the range of 10%. But if we would look at the entire R&D value, we are 34% of the overall R&D which is existing in electronics. So it's quite high compared to the whole chain. And finally, we do electronics thanks to material suppliers, wires, resins, silicon itself, and that's how we build our products. So I will focus for sure on our part. starting by saying that the localization of the electronic components in the world is mainly in Asia. You can see this is not ST data, this is a worldwide data in 2011. About 70% of the products were manufactured in Asia, which is more or less what we see for ST customers by shipment, so where we ship our chips to be assembled on a phone or on an automotive electronics device, so more or less the same. A bit more in Europe. We are a European company, French, Italian company, headquartered in Geneva, and therefore historically, we have a bit more than usual European customers. But now, and this is very important for the R&D, the third part is where are our customers by origin? So where do they design their devices? And it is more or less one-third, one-third, one-third between Asia, Europe, and the US. So typically, big mobile phone makers in US would produce in Asia, so we would ship our device to them in Asia, but they would design in California, okay? The same for automotive components, mainly in Germany, designed in Germany, produced in Asia. This is important, and I will come back on that, because when we do R&D, it's important to be close to the manufacturing centers, but it's also very important to be close to the designers, so the people who will decide what chips they want to put in their final product. So one slide about ST in terms of figures. So we are a 50,000 employee company, as I said, European. We had in 2011 a little bit less than $10 billion revenue. And 12,000 people are working in R&D out of those 50,000 people. You will see the manufacturing sites later, so we are well spread across the countries and the regions, but out of the 50,000 people, and this is important, we have basically half of our employees in Asia. You will see it later, a lot in manufacturing, but not only. So, one first map, you will see many maps in this presentation. One first map is to show you where we produce. I have started by showing you those two pictures. As you know, we are doing silicon devices, chips. They are done on what we call wafers. Wafers is a disk made of silicon, and we grow a lot of technology on that, and that's how we do chips. And when all the small squares that you see here are a chip. So the bigger the chip, the less you have on the wafer, and this is basically the scale of this industry. We don't sell wafers to our end customers. We sell packages. So what you see here is a chip, small wires, connections. You probably recognize the leads, metallic leads that you see at the outside of a package. So that this is what we serve, and this is what our customer will mount on their boards. So anytime you see a wafer, that's where we produce in France, so in Tours, in Grenoble, in Aix-en-Provence, and in Italy we produce in Milan and in Sicily. So this is the roots of ST. But we have now our biggest wafer fab in Singapore, in Amokyo. So for those of you who know, this is where we produce the highest quantity of wafers in the world, of a small size, so not as big as in Grenoble, but still a very high production. And what you see in green is what we call the back end, so the end part of the production, the packaging. So the packaging is based in production in Morocco and in Malta. Don't ask me why Malta, it is historical. I think it was close to Sicily and Italy. Nice place, by the way, when we talk about a nice place to live for quality of life. And we produce in Malaysia, in China. We have 2 plants in China, close to Shenzhen, and 1 plant close to Manila in the Philippines. Now, those triangles here are where we do packaging R&D. So, as you see, they are close to where we produce. Okay, we put a bit more in Europe because this is close to our customers, and we put also a lot in Asia, close to our manufacturing centers and close to our partners and suppliers. So this triangle is a network of R&D, and by the way, this is a team that I'm leading. So it's about 280 people in the world and a budget of about $30 million a year. So you see here a typical assembly line. So how we would transfer a chip which is on a wafer, like the small model that you had on previous slides, to a package that you see here. So we will go through all those steps, which is here this is a fully automatic line, but we may not have always this fully automatic. And we will cut the chip. I will go through those key steps. We will cut the chips to put them inside the package. We have big evolutions in our industry to go to more density, so higher density, higher miniaturization, lower cost. And this is to help you to have phones, GPS, cars with more electronics, more integrated. You have a lot of things now in all the electronic devices that you carry. This is thanks to packaging. If we are not able to make the chip and the package smaller and smaller, you won't have so many functions in your pocket today with your portable devices. So, what means designing packaging and simulating packaging? First, we have some electrical engineers who are transforming the signal of a chip through some wires, and they model it electrically, and they verify that the chip will work well in a given package. They verify as well that thermally it works. Microprocessors of Intel, for example, are dissipating a lot of heat. We put heat sink on it, and without this thermal management, it would just burn the application where it works, or your phone would burn your ears. Okay, there is, by the way, a rule which says that we cannot have more than 40 degrees on the phone, otherwise it's heating too much. And this means that we have to work a lot on how we will remove the heat from our packages. And finally, the mechanical aspects. When you drop a phone or when you put a device under high temperature or low temperatures, all the components may suffer. So we have to choose the right materials to make sure that it will be reliable for years. So this means some physics and some mechanical science. I'll bring you now through 3 steps of, that's what I call the MRT line. If you see the MRT line, these are the steps of assembly that we do to bring a chip to a package. First, we glue the die. First step, we glue the die. So we take the die from the wafer, we put some glue, and we will attach it on the carrier. Second, and that's the key step, we wire the die. We connect the die from the chip to the substrate. So those wires are as small or in diameter as your human hairs. Okay, it's about 25 micron diameter. And finally, we need to mold, so we need to put some resin around, and basically we receive this type of resin from our suppliers who are all in Asia, and we transfer this small compound to create a package. So all of that is done with key partners. And I will show you this slide, and you will see it at the end of the presentation to understand how Asia is geared now to face this R&D. So the key partners that we have this is a target. We want to have the best package at the lowest cost and at the highest degree of integration. We need to work with the proximity of our customers, with wafer fabs who are creating the wafers, mainly in Europe, but also one fab in Asia, with people and the skills, the materials that are used to create a package, equipments, R&D institute, fundings, and assembly plants. So now I'm going to one example of packaging to show you how Asia is contributing to this. A challenge that we have in packaging. You may know that the gold, if you invest a bit, the gold is going very high, and we are trying to change from the gold to the copper. And I'll skip this one, it's a bit detailed, but just to tell you, in fact, copper has increased a lot. If you look at the London Metal Exchange, you would see that copper has been multiplied by 6 in the past 10 years. From $1,500 to $8,000 per ton. So that's a lot. Gold, and that's not a coincidence, but or that's probably, a coincidence, but gold has also been rising a lot, multiplied by 6 also in the past 10 years, from $300 per troy ounce, which is 31 grams, to $1,800 per troy ounce. So both have been multiplied by 6, but if you compare on the same scale, this is where copper here is, so the same curve on the same scale compared to gold. So huge ratio. In fact, the ratio is in the range of 7,000 between gold and copper per gram. So what does it have to do with packaging? We are forced to remain competitive and to avoid to charge your mobile phones or your car electronic devices, whatever, to a higher price, we are forced to go fast from the gold to the copper. Otherwise, it may continue to increase. So that's a packaging innovation. And we have been doing that in the past 9 years with a strong acceleration recently. These are the 10 billion packages since day one that we have produced with copper wire. And if I would make an image in terms of length of wire, we have already converted the wire that we use in packages from gold to copper at an equivalent length of 700,000 kilometers. So you are able to go back from the Earth to the Moon with all the wires if you put them one after the other in our industry. So how did we do that? We worked with our suppliers of materials, the people who are giving us the wires, the resin, the frame. We work with our wafer fabs to design the chip correctly. With equipments, equipment suppliers are mainly in Asia, so we have to make them help us to go faster in this change. And obviously with people. And I will insist a bit on this point because we have good engineers in Europe, definitely, but there are many, many good engineers in Asia thanks to the manufacturing network which is here. So if we want to find an expert in this field of what we call wire bonding in packaging, in Europe, I would have difficulty to find one expert with many years of experience just by advertising. In Asia, I would have plenty of offers. So that's a great advantage. The only step back is that we have difficulties to keep our engineers as well. And so the retention is a challenge in Asia. And this is why a mix between the two is wise in our R&D. Back to my target, and this is, I'm coming to the end. Back to my target. So we have first, in manufacturing infrastructure, the assembly plants, the people who are doing packaging in this industry are today 55% done by subcontractors, so people we send chips to and they assemble for us. We are integrated, so we do it on ourselves. But those subcontractors are, as you can see, mainly in Asia-Pac and Japan. So manufacturing-wise, this industry is in Asia. The customers is about one-third, one-third, one-third. So proximity to customer, Asia, I would not say has a great advantage, but it is an advantage for my particular packaging industry. For design and so on, it can be different, but for my particular packaging industry, it is good, but it is not enough. Wafer fab, so the guys who are producing the chips, Europe, US, Asia, it's about also one-third each, so it's well balanced. We need to further increase the links between the front end and the back end, so the chip and the package. That's why we keep strong teams in Europe. People, I just commented it before, very strong in Asia, and it will remain very strong. The only point is keep them, so have attractive schemes to make sure that those experienced engineers stay with us. Material and equipments, remember my wires, the resin, remember the machines that we use to connect all of that. The industry is here. It's even in Singapore, it's in Japan, it's in China for sure, in the Philippines. So if we want to work with suppliers, there is very few equipment suppliers now based outside of Asia. R&D institutes. Here I'm comparing the R&D institute that we find in Asia compared to the one in the US or in Europe. They are good, but they could be better. So I have not put you see the pie to the maximum. I think the innovation is a bit young still in this industry in Asia. We are producing in Asia for the past 40 years, but we are really developing for only the past 5 to 10 years. And the R&D institutes are more or less in line with that. And finally, the fundings. There are good fundings in Asia. Compared to Europe, maybe they are less organized as a group. If you know for sure the funding plans in Europe, you have a lot of European community fundings for our industry. In Asia, it's more country by country, but in Singapore in particular, we are glad EDB is financing a lot, and we have good partnership with them. They helped us to start our industry in Singapore. The target is full if you have a global R&D, if you are able to take the strengths wherever they are, Europe, Asia, and a bit of US. Okay, so as a conclusion, we've seen that the technology is global, and we want to benefit from all strengths. We want to benefit from all strengths. And Asia has a strategic positioning, definitely. It is cost competitive to attract, and this is what started the manufacturing, but today this is not the only reason why we are here, for sure. We have built a manufacturing infrastructure, and now all the main actors of the value chain, suppliers, people, engineers, everybody is in this region. R&D Institute, so this is following. There is a slight gap compared to what we have in Western countries, but this is well following. And for sure, having teams, as you've seen, I have teams in Europe, I have teams in Asia, so communication is helping a lot, conference calls and so on. This is making things easier. We still have to travel, but it is possible today, for sure, to have teams in remote places. And with that, I will thank you for your attention.